Okay, hi everybody. This is Mrs. Melcher here. Today we're going to be talking about ideal gas law stoichiometry. And this is going to be how you will solve for problems using the ideal gas law and stoichiometry. Now, if you remember the ideal gas law, it's PV equals nRT. PV equals nRT. And I always say it to myself out loud just so that I remember what order it goes in and so that I can find the different things that I'm looking for. P stands for pressure, V stands for volume, N for number of moles. R is going to be a constant, which will vary depending on what your pressure that you choose is, and T stands for temperature. And remember that temperature, when you're using the ideal gas law, is always found in Kelvin. Okay, now I have a example question set up, and I'm going to go through the example question and solve for that. Here's the question. What volume of hydrogen gas is evolved from a reaction between 0.52 grams of sodium and water when the gas is collected at 20 degrees Celsius and 745 millimeters of mercury? All right, so this problem does give me the equation, but sometimes they won't give you the equation and you'll have to solve for that. The first thing that I like to do is just get my PV equals nRT at the top of the page so that I can use that later when I'm trying to find my different values. I'm going to switch colors here because that one's not working quite as well. And then just use your equation that use your problem that you're given and try to start filling in as many blanks as you can so that you can solve properly. What volume of hydrogen gas? So I am going to be looking for the volume of hydrogen gas from a reaction between 0.52 grams of sodium. So I'll be starting with that. That means I'm going to have to solve for this part first in order to solve for the hydrogen. I'll write that down over here. 0.52 grams of sodium. And I'm going to convert that, doing some dimensional analysis, some stoichiometry, in order to find the hydrogen that I'm looking for. I will be able to plug that in for the final equation. All right, some more things I can fill in here. The gas is collected at 20 degrees Celsius. So remember, like I said before, it's not going to be measured in Celsius, it's going to be in Kelvin. So to convert, just add 273. Okay, so it's going to equal 293 Kelvin. All right, and 745 millimeters of mercury, that's my pressure. Now, if you want to figure out R, like I said, the value, it depends. R is the constant. But I have this chart printed out. Yours is in your book, or else you can use the one that you printed out. So yeah, this one says millimeters of mercury, so you're going to want to be using this value at the bottom, 62.4 for that. Okay, so I'm going to solve for, I'm going to convert this to hydrogen, because that's what my question is asking me about, and then I'm going to solve, and then put that in for N, and then I'll be able to solve for V using the PV equals nRT. Okay. All right, 0.52 grams of sodium. First thing you need to do is convert to moles of sodium. There's 23 grams of sodium in 1 mole of sodium. So I canceled that unit. Now if you take a look at your equation, you're next going to be looking at the mole ratio. So sodium, I see it has 2, and that's what I'm going to be canceling. 2 moles of sodium for every 1 mole of hydrogen. Okay, so I've canceled my moles of sodium, and now I'm at moles of hydrogen. And that's going to be good because I want to know the number of moles, so I can plug it in up here in my N, and then I can solve PV equals nRT. Can you see this quite? Yeah. So I'm just going to plug that in the calculator, see what I can get for a value. Hopefully you're following along. If you have questions, you can post them in the comments, and I'll make sure that I check, since I know that some of you are gone or some of you are not quite understanding this. All right, so my value for the moles of hydrogen is 0.0113 moles of hydrogen. Okay. All I did was I converted from grams of sodium, which is what my problem gave me, to moles of hydrogen, which is what my problem is asking about. Okay, so for my n value, it's going to be 0.0113 moles. And now you simply plug that in for PV equals nRT. I'm going to scoot this over so you can fully see what I'm doing. P is 745 times V, which I don't know, equals N. Right here, 0.0113 times R. Remember how I chose my R? Because I looked up to see that I was using millimeters of mercury, and then times temperature, 293. Okay, if you remember algebraically on how to get V by itself, you will just divide by the 745. I'm going to cross it off and put it down here. 745, and that's my millimeters of mercury. Yeah, having units is important here. I'm just trying to go through it quickly so that you can understand. I'm plugging into my calculator right now. Sometimes I've noticed that students, they have the whole problem set up right, and then they have some calculator error, and that can definitely change things. So you're going to want to double check and make sure that your answer makes sense. Okay, when I plug this in, the value that I got for V is 0.277 liters. All right, thanks for staying tuned and just trying to work through these problems. There's a few more problems. If you're questioning, you can work into the book. And if you have questions, like I said, just post down in the comments. All right, thanks for listening. Bye.